Hello everyone. Today I, Shruti, Kyle, Emmanuel, and Ishan are going to talk about Hbase. So first of all, introduction and installation. Hbase is a column-oriented, non-relational database management system that runs on top of Hadoop distributed file system. Now, what do we actually mean by column-oriented? Let's bifurcate these definitions. So by column-oriented, we mean that Hbase stores data in the form of key value pairs in a columnar model. In this model, all the columns are grouped together as column families. Now, we all know what non-relational database management system is, but what exactly is Hadoop distributed file system? Hadoop distributed file system is the primary data storage system used by Hadoop applications. It employs a name node and a data node architecture to implement a distributed file system that provides high-performance access to data across highly scalable Hadoop clusters. Now we see that in the contemporary world, with the concept of big data really gaining weight and gaining momentum, what we see is big data and data streaming and transfer of big data has become a really big thing. So how is Hbase important is that it is well suited for real-time data processing or random read-write access to large volumes of data. It provides a flexible data model and low latency, access to small amounts of data stored in large data sets. Now, Hbase on top of Hadoop also increases the throughput and performance of distributed cluster setup, and in turn provides faster random reads and writes operations. So yeah, again, Hbase system is designed to scale linearly. As we talked about it, it comprises a set of standard tables with rows and columns, pretty much like a traditional database. Well, how we read about in MySQL. Now, each table must have an element defined as a primary key, and all access attempts to Hbase tables must use this primary key. So yeah, we're familiar with all this. Now we're going to talk about some basic structure nomenclatures in Hbase. So there are tables, rows, column families, column, namespace, cells. But what exactly are these? Now, tables are collections of rows. Rows are collections of column families. A column family is a collection of columns. Those columns which are related to each other by some specific particular heading. We'll see that. Column is a collection of key value pairs. Namespace is a logical grouping of tables, and a cell is always written in the row column version tuple, which exactly specifies the cell definition in Hbase. Now this is basically the structure. So you can see the first column is the row ID, and then different columns are grouped under different column families. Now we get to the installation process. In the installation process, there are three modes of Hbase installation. There's the standalone mode of installation, pseudo-distributed mode of installation, and fully distributed mode installation. So these three definitely differ. In the standalone mode, it doesn't work on Hadoop, but it's the least complex, and this standalone mode is what I'm going to discuss. I've made a small tutorial which I'm going to share with you, in which I actually walk through the whole tutorial on how to actually install Hbase on your CentOS file system. So let me share that with you. So yeah, let's resume with the Hbase installation. Hello everyone. Today site right here, and you have to select a stable. You through how to download Hbase in the standalone mode, and for this we first have to go to the Apache website right here, and you have to select a stable version of Hbase. I selected 2.2.6. You can select any that you prefer, or which is in accordance with your machine and everything. So you're gonna get this tar file from Apache's website, and you're gonna HCP or use FileZilla to get it in your VM machine. So let's get into the VM machine first. I'm just going to walk you all through the steps that are in the download. I've done those steps, but for the convenience of time, we're going to just rush through the steps real quick. So first of all, what we're going to do is we're going to go and see where we actually have our Hbase folder. So if I go to my home folder, you can see that the blue colored Hbase folder is the untarred one, which I got from the red colored tarred GZ file. Once I untarred it, I could actually go inside and see what's in that folder. So let's do that. Yeah. Here we are. So it has all these folders within it. It has bin configuration and all these folders. So we need our configuration folder. Here we have further a lot of scripts which we can edit and which we will edit. So first of all, we're going to go to the environment script and edit that one. .sh. Again, I have done this process. I'm just going to show you and walk you through. So here it is. It's I'm highlighting the path that you have to mention, the changes that you have to do to this file so as to help you in the installation process. You have to mention your Java path right here. And my Java is located in my library. It's usually located in the library. And this is my Java home path, and you have to mention yours. Now I'm going to exit from here. And next we are going to edit our bash or C file. So what I'm going to do is I'm going to go here we are. Again, I have my Hbase path here, and the highlighted stuff is what you'll have to actually change in for your installation. So I have my Hbase path, and this you're going to mention where your Hbase is located in your VM virtual machine. Mine, as you all saw, was located under my home folder, under my names folder in Hbase 2.2.6. And you also have to include the Hbase in the path, the main path. That's what I've done here. Again, let's get out of here. And now where we're gonna go is we're again gonna go to the configuration. We are in the configuration. So where we're gonna go now is the Hbase site.xml folder. So let's open that. Here it is. Here, what you're gonna do is you're gonna add two properties in this particular file. One for the Hbase root directory, and one you have to add for the data directory, which corresponds to the zookeeper. I'll show you how to do that. So, and I'm going to highlight and show you what changes I made to actually, this is the changes. These are the changes I made. I added my root directory right here, a property, and I added my data directory right here. This is how you have to add in. Again, it includes where your Hbase folder is located. So that's instead of Shruti or /home/Shruti, you have to add your own user base folder where your Hbase folder is located. I'm going to exit from here. And now we're going to edit our host files in etc. So we're going to go right there. So I hope you all can see the hosts file at the top in the H column. And this is what we're going to edit next. So here it is. I have mentioned where my local host or whatever user or machine I'm using. I'm using localhost right here. Whatever machine you're using, you'll have to mention its IP address. I've mentioned mine. So this is what you have, all you have to do in this hosts file. So now is our final step from where we can actually run and get into the shell scripts. What we're going to do is we're going to go to the bin folder in our Hbase. So that's what where I'm headed next. So here's my bin folder, and here its contents. You can see all these marked in green are the shell scripts which can be executed, which can be run. What we have to do first for this is we have to run the start hbase dot sh script to start our master daemon. Once you execute that, the next thing you'll have to do is you'll have to enter the Hbase for the green Hbase command, and you'll have to enter shell to open the Hbase as a shell. So this was a quick walkthrough to how to open and execute the shell, and thank you very much. I hope. So yeah, this was my small installation tutorial to install Hbase in standalone mode, and this was all about installation and introduction. And my friends, my teammates are going to talk more about Hbase. Thank you.
Hello, my name is Kyle Conti, and today I'm going to be going over the basic usage of Hbase. So, the basic usage of Hbase. Well, first, I'm going to categorize these commands into three different categories: general commands, table management commands, and data manipulation commands. So first, let's start off with general commands. So general commands are mostly commands about the system. So status. Status provides details of the system. So pretty much it provides information about the system. And you can use three parameters. There's summary, simple, and detailed. And summary is the default if no parameter is specified. And the name says what they say, and the names suggest on what they mean. Summary gives you a summary of the status. Simple, it gives you a quick little couple lines of the status, and then detail gives you like a big huge chunk of information. So now version. Version's pretty simple. Shows the current Hbase version being used. Pretty straightforward. Table help. So table help kind of works as manual works in Linux. It's pretty much you type in table help, and then you type in a certain command that you want to learn more about and know how to use better. So table help helps users by showing them how to use a certain command. And then who am I? Pretty simple. Provides the current Hbase user information. So who's using the Hbase server right now? Pretty straightforward. All right, so next is table management commands. So table management commands pretty much affect the structure of the table itself. So let's get to it. So create command. So the create command requires the table name and a table name for your new table and the column family names. So pretty much just your columns that you want to add to the table. And this creates a table with certain columns. It creates the structure of the table. It's pretty much what we do in MySQL. Pretty much the same thing. It's a little bit different syntax. List. So list shows all the tables in the your Hbase system. Again, pretty straightforward. Next is describe. So describe, when you describe, you have to specify a certain table name, and describe pretty much gives all the information about the table, such as their column families information, like the data size of it, stuff like that. All right, next is enable and disabling, and then you need a specific table name. So pretty much the enabling and disable command does what it implies. It enables and disables the specified table that you entered in the parameters. And we will dive into more on why you need to enable and disable tables. But for now, just know that enable and disable does that. All right. And then we have enable all and disable all, and then a matching regular expression. So pretty much what this command does is that it enables and or you can disables all the tables that are matching your regular expression in the parameters. So for example, say you wanted to disable all the tables that started with the letter E. You could do that. Pretty straightforward. All right, next, table management commands continued. So we're just continuing on another slide of table management commands. All right, so the drop table. All right, so pretty much dropping is you're deleting a table and then you specify what table you want to drop. Now, this is where disabling comes into play. You have to disable the table, a table first before we can drop it or delete it. If we do not disable a table first, then we are unable to drop that table. So it's very important to disable a table before you drop it. All right, then the drop all with a matching regular expression, pretty much same concept as the enable slash disable all for matching expression, regular expression. So it deletes all the tables that match the regular expression that you have specified. Or you don't have to have a matching, or you don't have to have a regular expression for it to match. You could just drop all of them. Show filters. Straightforward, displays all the filters that are enabled in your Hbase system. Then we have alter. So alter pretty much just, it manipulates a table. So like the structure of the table. So you can, that's this how like you would add like a certain if you wanted to add a new column, you could do that, stuff like that. So changes a table's structure. All right, next we're going to move on to data manipulation commands. So these commands allow you to insert data into the tables, retrieve data from the tables, stuff like that. So let's continue. All right, so we have the count command. So the count command retrieves the count, the number of rows, and the default cache size is 1,000. You can change that, but the default is 1,000. So that's pretty straightforward. And then the put command. So the put command inputs data for a specific cell. So you have to specify your what table name you want. I mean, you have to specify your table. Then you have to specify the row number and then the column number, value, whatever you want to call it. And then you have to specify the value that you want to input into that cell. So kind of like Battleship in a way. Yeah. You go across, vertical, oh, there's your cell, then you input that data, that value that you want to input into this cell. All right, now get. Get is kind of like select. It retrieves the row slash cell contents of the table. So you would do your table name, then like your row name, and then any additional parameters that you want to add to that get command. And these parameters include timestamp, time range, versions, and filters. And there's many more too, but these are just a few that you are able to use for the git command. All right, so next is the delete command. So the delete command pretty much just deletes the data and deletes the cell contents given in the row/column. So it just deletes the value, the data in the cells that you have specified. All right, so this is a data manipulation continued. So next we got the delete all command. So the delete all command is pretty much the delete command, except this time it disables and deletes contents in a row of the table. So it deletes the entire row pretty much. Yeah, pretty straightforward. I mean, when I say it deletes the entire row, it deletes the contents, the value of the value in those cells. Again, does not delete the row itself, like the structure. Does not do that. All right, now truncate. Truncate's kind of weird. So when you truncate a table, first what it does is that it disables that table. Okay, so it makes the table unavailable. Then you drop the table. It drops the table. That's what truncate does. You don't drop the table, it drops the table. And then it recreates that table. So reason why you'd want to do this to be just refresh a table. Just like refresh like the data and everything. Truncate's kind of weird, but it's a command. All right, then we got scan. With scan, it scans the table and displays the contents. So again, this is pretty much like this is like the select command as well from MySQL. So it retrieves the data from our table, and then we can add additional parameters. Like, for example, we can add time range. We can do filter, timestamp, the limit, the max length, columns, the cache, and then the start row. Oh, and stop row. Forgot about that one. So those are all the filters those are all the parameters that we can use for the scan command. All right, and these are some of my sources for the basic usage. And next, we will be talking about the uses, cases, and industrial adoptions. Take it away.
Okay, so I will be discussing about the industrial adoptions and the use cases of Hbase. So Hbase can store billions of rows and millions of columns, which makes it mainly used for sparse and big data. It is also suited for this because it can contain lots of missing or any values. Okay, so what do you mean by big data? So based on the Oracle's definition of big data, it has three V's, which are volumes, volume, velocity, and variety. By volume, we mean that there is hard to predict volume of data, and which is very high. And velocity, the data is received in a very fast rate. And variety, there are many types of data that are going to be available. Plus, it is unstructured, whereas traditional data types were structured and fit neatly in relational database. So what qualities of Hbase makes it used for big data? So it supports a big data volume. It has a good hardware environment that can handle this for both for storage and retrieval of the data, which is the Hadoop file system that is discussed in the previous slides. And three, it has no requirement of relational feature, and it also has quick access to data. Who uses Hbase? The banking industry generates millions of records on a daily basis. The telecom industry has to store billions of call detailed recording log records generated. So Hbase is used to store billions of rows of detailed call records. If 20 terabyte of data is added per month to the existing RDBMS database, performance will deteriorate. To handle a large amount of data in this use case, Hbase is a fine solution. The same would be for social media networks. For example, Facebook is using Hbase to power its message infrastructure. Facebook selected Hbase due to the excellent scalability and performance for big workloads, along with offload balancing and failover features, and so on. Adaptions. One of the applications of Hbase is to connect to a Google Cloud Bigtable instance, perform basic administrative tasks, and read and write data in a table. So Cloud Bigtable is a database developed by Google, and it's one of the popular NoSQL database systems available. So Apache Hbase was created based on Google's publication, which was the Bigtable, a distributed storage system for structured data, which was initially released in 2008. There is also a Cloud Bigtable Hbase client for Java, which does similar tasks to JDBC that we discussed in class. Assuming the time we have, let's demonstrate connecting Hbase to a Bigtable instance on Google Cloud Console. Okay, so I'm about to demonstrate using Hbase with Bigtable, and if you want to set up this and try it at home, there's a good walkthrough that you can find. We have provided a link on our slide, and it will show you how to create the CBT, the Cloud Bigtable instance, and then install Hbase shell on your cloud console. But since just like I have said earlier, we don't have enough time to demonstrate all this, so let's just see how. I have set up this already, and let's just see how I'm using it. So this is my Google Cloud console, and though the first thing you have to do is create a project, of course, and this is the Google Cloud Bigtable instance I have created. So I have to create this first in order to use it for my Hbase shell. And you also have to enable your API and credentials and other billing stuffs. You can find all that on the walkthrough. And okay, so now let's try to access the Hbase shell. So this is a file that I cloned from GitHub, and it's a file that can let you. You can just assume that like it's already well-written code that can let you connect your Hbase with the CBT. There we go. So this is the Hbase shell, and as you have seen it in the previous slides. And now let's try to do some actions here. So let's see, if we do list here, we can see this table. We can see that we can access this table that was created here, and let's try to create another table. Let's say this is a school. It's going to be a school database. And if we refresh this, we have to see that oh, okay, so my Cloud Shell would be, I have to restart the Cloud Shell again. Okay, but that's fine. And then if we go to the tables tab, you can see that we can access the, you can see that the school table we created was visible on the big table instance. And yeah, and that was pretty it. You can perform any type of Hbase commands here, like the put command that was discussed earlier, and any other stuff. Any other thing that you can do Hbase, you can do in Hbase, you can do it from here and actually use the big table database system. And that was it. Also, we will be discussing limitations and comparisons of Hbase in the next slide.
All right, I'm now going to talk about some limitations of Hbase. Even though Hbase has many useful advantages over SQL and other no SQL-based DBMS, such as fast retrieval of data, being able to work with sets of sparse data, being scalable and dynamic, and it's pretty versatile in handling data that is unstructured, semi-structured, or structured. It does have some disadvantages. The cost of failure associated with Hbase data management system is extremely high because Hbase architecture always has a single point of failure, and there is no exception handling mechanism associated with this. If in any production environment Hbase is running with a cluster of more than 5,000 nodes, only Hmaster acts as the master to all the slaves region servers. If Hmaster goes down, it can only be recovered after a long time. Having another master is definitely possible, but only one can be active at any given time. And it will take a long time to activate the second Hmaster if the main Hmaster goes down. So Hmaster is definitely a performance bottleneck associated with Hbase. Hbase also does not support any kind of SQL structure or querying. Hbase cannot perform functions like SQL. It doesn't support SQL structure, so it does not contain any query optimizer. In Hbase, we cannot implement any cross-data operations and joining operations. We can definitely implement joining operations using MapReduce, but that takes a lot of time to design and develop it. Table join operators are difficult to perform in Hbase. In some use cases, it is almost impossible to create join operations that are related to tables present in Hbase. This lack of cross-compatibility also means that Hbase would require new design whenever we want to migrate data from RDBMS external sources to Hbase servers. And this process, again, takes a lot of time and is very resource intensive. Now, talking about being resource intensive, one of the major drawbacks with Hbase is that we cannot have more than one indexing in a table and only the row key column acts as a primary key. So the performance is going to be slow whenever we want to search more than one field, or if we want to search along some other key except the row key. This problem can be overcome by writing MapReduce code and integrating it with Apache SOLR and with Apache Phoenix, but that is again time intensive and requires expertise. Hbase is CPU and memory intensive with large sequential input or output access. While MapReduce jobs are primarily input or output bound with fixed memory, Hbase integrated with MapReduce jobs will result in unpredicted latencies. There are some other disadvantages overall. There are slow improvements in security for different users to access data from Hbase. Hbase does not support partial keys entirely. Hbase allows only one default sort per table, and I don't think there are any ways to change that. It's very difficult to store large size binary files in Hbase. The storage of Hbase will limit real-time queries and sorting. Key lookup and range lookup in terms of searching table contents using key values will limit queries that perform on real time. Default indexing is not present in Hbase. Programmers must define several lines of code or script to form indexing functionality in Hbase. It is expensive in terms of the hardware it requires and the memory blocks that it needs to be allocated. And that wraps up the disadvantages associated with Hbase when compared to other DBMS.